So here's another example. First, we check to see if it's in standard form. So when we're talking about that, we want to have the squared term, then the m term, the linear term, I guess, and then the constant. All right, now we identify A, B, and C. A is 3, B is 12, C is 7. So we find our formula. Like I said, I always write it down. There it is. And then I'm going to put in A, B, and C. So the opposite of 12 plus or minus the square root of 12 squared minus 4 times 3 times 7 all over 2 times 3. Okay, so if I've got all the numbers where they're supposed to be, then I start simplifying. So negative 12 plus or minus 12 squared is 144 minus, now what's 12 times 7? I think it's 84. I probably better check that. Yeah, that looks like 84 to me. Okay, all over 6. And so we've got one more thing to do right now. We've got to do that subtraction. So negative 12 plus or minus the square root of, and then 144 minus 84 is going to be what, 60? Now, when we get it down to this point, we don't, 60 is not a perfect square, so we're not going to be able to take the square root of it. We can simplify, though, and so we want to be able to do that. So 60 breaks down into 15 times 4, and I can take the square root of 4. So I'll have negative 12 plus or minus 2, because the square root of 4 is 2, radical or square root 15, all over 6. Now we can do a little bit more, because in the numerator we could factor out a 2. So you think about 2 times negative 6 is negative 12, and then 2 times the square root of 15 would be 2 times the square root of 15. Now 2 cancels with 6, and putting that as a 3. And so I have two answers, negative 6 minus the square root of 15 over 3. And I would write it that way. And then negative 6 plus the square root of 15 over 3. And then those are going to be the two solutions right there. So that one's a little bit different because we get irrational numbers for the answer.